Okay, welcome back to pre-calculus. We have a rational function here where we have to figure out the vertical and horizontal and oblique asymptotes. We'll go ahead and take that in there. Okay, figure out if there's any discontinuities, any holes on top of the asymptotes, and then give us a brief sketch of the graph here. So with rational functions such as this, my first advice is factor everything. So this one's a cubic. Okay. How we do that? We don't have any formulas for, well, we have a formula for cubic, but this one doesn't fit the pattern, so we don't have to worry about that. But I usually say this is usually designed for you to be factoring by grouping, and I would do with first pair, second pair. It's the most common thing you're going to have. You could also group them as 1 to 3, 2 to 4. That's also a usual thing to deal with. It could happen that you have a grouping of 3 and 1. That does happen. It's just not very common that it happens that way. So I would try the first pair, second pair grouping first. Okay. For my first pair, second pair grouping, I'm just going to factor the top here. We're going to factor an x squared out of the first two terms. So that's going to give me an x minus 3. And then we're going to say minus 4 out of my second terms, and we have an x. Now, I factored out the negative sign, so that's going to be a minus 3 here. So we're going to be able to factor out this x minus 3. So we have x minus 3 with x squared minus 4. And we're going to say that's x minus 3, x plus 2, x minus 2. And that's going to, or x minus 2, or not 4. And that's going to be our fully factored numerator. Now, in the denominator, x squared minus 3x minus 10, okay, it looks like we're going to have an x minus 5, x plus 2, another thing to deal with. And it's like, oh, would you look at that? So it factored out pretty simply. And we're also going to say, wait a minute, this x plus 2 is top and bottom. We could cancel that. We're going to write this over here as x plus 2 equals 0. X cannot be negative 2 because if we put that back in here, even after you factor it, I put it back into my original equation, we're going to get a 0 over 0 situation. This part is a hole. Okay, so we're going to have to go figure that out now. So let me go ahead and take a look at what's happening. We have an x minus 3, x minus 2 divided by x minus 5. We'll go ahead and multiply this out because sometimes it's nicer to look at it that way. So there's going to be an x squared minus 3 minus 2 minus 5x plus 6 all divided by x minus 5. Now there's nothing more to cancel. We've already done that. What I have to do is I have to say, hey, there's a vertical asymptote, okay, at x equals 5. There's a hole at x equals negative 2, and we'll get to that in just a moment. Okay, but right now we have x minus 5. Now I have to inspect the degree of the top and the degree of the bottom. Well, the degree of the top is 2. The degree of the bottom is 1. The top is 1 bigger than the degree of the bottom, which means this is everybody's favorite thing to do. We have to do polynomial division in order to figure out what my oblique asymptote is. We have x minus 5 goes into x squared minus 5x plus 6, and we have to go ahead and sort this out. So the first thing I'm going to do is say we have an x squared, or an x rather, not x squared, just x. And we're going to go ahead and multiply this through. So we have x times x, which gives me x squared, minus a 5x, and then we're going to subtract it. X squared minus x squared, we get 0. 5x, negative 5x minus a negative 5x, negative 5x plus 5x, we end up with 0. So we have a remainder of 6. Okay? And we don't have to worry. It's almost like somebody did that on purpose for you. So we're going to see whether or not x goes into 6. It doesn't. So we're done at this point. So our oblique asymptote, okay, is simply x equals, or y equals x. Okay, go ahead and do it that way. As y is equal to x. Okay, now we also have to deal with the location of our hole. Okay, and what did we find out the location of the hole is? It was x is equal to negative 1. Or negative 2 rather, x is equal to negative 2 up from up here. And then we have to plug this back into our function, the function that we've reduced already, and then deal with it that way. So I could plug this x equals negative 2 back into this spot right here, and you could do it either way you'd like. I'm going to do it as x minus 3, x minus 2 divided by x minus 5. I'm just going to go ahead and plug in my -2. So we have -2 minus 3 times -2 minus 2 divided by -2 minus 5. Okay, so we have to do a little bit of arithmetic here. Your $2, you spend $3 more, you're going to have -$5. Okay, your $2 and you spend another $2, and we're going to have -$4. And then we're $2 and we spend $5, we're going to be at -$7. We have 1, 2, 3 negative signs, so it's going to be a negative number. So we're going to end up with the y value of 20 over 7. Actually, it's negative because there are 3 negative values here. So the whole location, right, is at -2, -20 over 7, right, which is 3-ish. Okay, you have a calculator to kind of help you out with that, but I don't. I know that 20 over 7 is real close to 21 over 7, which would be 3. So this is a little bit lower than 3. Right? So here is we have all the features of the graph kind of set out for us. We have a vertical asymptote, we have an oblique asymptote. We are good to go with this. All right. So next thing that we're going to do is we're going to go ahead and start thinking about sketching in this graph here. All right. So right now I have a vertical asymptote. Where's my vertical asymptote? Vertical asymptote is at x equals 5. Okay. So here we go. 1, 2, 3, 4, 5. So I'll go ahead and dot in an x equals 5 as a vertical asymptote. Okay. We also have an oblique asymptote at y equals x. So here. Okay, so I'm just going to kind of try to dot this in as best as I can and see if I can't get this to come out. All right, so there we go. We also have a hole at -2, -23rds. So -1, 2, and 23rds. Is 23rds a bigger number or a smaller number than x is at that point? It's a smaller number, so it's going to be down here somewhere. Okay, it's going to be on our graph, but I don't exactly know where that is. Okay, we have to go ahead and plug in some other points in order to figure out what's going to happen here. One of the points I might want to figure out is where is this function equal to 0? Since I have this in its factored form, we have x minus 3, x minus 2, x minus 3, x minus 2 over x minus 5. Where is this equal to 0? We cross multiply on both sides by x minus 5. We have x minus 3 equals 0, or x minus 2 equals 0. X is going to be 0 at x equals 3 or x equals 2. Okay, so I can go over here and say, okay, we need 1, 2, and 3. All right. So I know this is where it crosses. Okay, we have a vertical asymptote sitting here. It's going to kind of go down and deal with my asymptotes. Okay, and I know that this piece is going to kind of go through over here. I would like 2 more points somewhere on the left or somewhere on the right side of my asymptote here. Okay. So we're looking over here. Now this is going to be a fun thing to have to draw because I'm going to be way up here on the second page in order to figure this thing out. Okay. So this was at x equals 5. Pick your 2 favorite numbers bigger than 5. I'm going to choose x equals 6 and x equals 7. Okay. In order to plug these guys in here. So when I plug in x equals 6, we have 6 minus 3 times 6 minus 2 divided by 6 minus 5. So I'm getting 6 minus 3 is 3, 6 minus 2 is 4, 6 minus 5 is 1. We're going to be at 12. So when x equals 6, y is equal to 12. So it could, if I wanted to make a little table down here, we could do that. Okay, we could say 3. Well, let's go ahead and say 2, 0, 3, 0. Here is my 6 and 12. We're also going to now do 7 because that was the other point that I was going to pick, 7. So I have 7 minus 3 times 7 minus 2 divided by 7 minus 5. So let's see, 7 minus 3 is 4, 7 minus 2 is 5, 7 minus 5 is 2. So we have 20 divided by 2, which is 10. So when x equals 7, we're here at 10. Okay. All right. So there we go. That doesn't quite feel right to me. So we're going to double check our arithmetic one little bit here. X equals 6. Okay. So yeah, we have 6 minus 3 is 3. 6 minus 2 is 4. Let's double check this. 7. 7 minus 3 is indeed 4. 7 minus 2 is 5. 7 minus 5 is 2. Okay, it just doesn't feel right. I might want to go through and just get back to the original function and see if we can't plug them in here and see what happens with this business right here. Okay, we might do that. So let's see. We have x squared minus 6x plus 5 plus 5. So we'll go back up here, just double checking it a different way. X squared minus, is it minus, where are we? Minus 5x plus 6. Minus 5x plus 6. If we, and it was also x minus 5 at the bottom, right? Yep, it's x minus 5. So I plug in 7. I just want to see if I'm getting the same answer. So here we go. We have 49, right? 7 times 7 minus 7 times 5, 35 plus 6, all divided by 7 minus 5, which is going to be 2. All right. So let's see here. We have 49 minus 35. So let's see. 5 from 9 is going to give me 4. We're going to be a 1 here. We're going to add 6 to it. So we have 20 over 2, which is indeed 10. Okay, I'm happy. All right, I just checked it both ways. Double check my arithmetic. We'll be okay with this. Okay, so we are with level 6. Oh, here it is. This is why. So 3, 4, 5. 1, 2, 3, 4, 5. This was 6 and 7. So we're going to be here. And by the way, when x is equal to 6, this asymptote is also going to be y is going to be 6. So when I'm looking at my values here, we are 12 and 10. So those are going to be a bit larger. Okay, they're going to be up here somewhere. They're going to be up here somewhere. So we're going to have a graph that's going to be looking like this on this for this this set of points up here, and we have a graph on the bottom looking at that. That's what our graph should look like. That's what our little picture should look like. We've collected a whole bunch of different points here, right? We could plug in 0 if we wanted to and figure out where it is at 0. Let's go ahead and do that. So if I plug in 0, we end up with 6 over -5. It's a little bit more than -1. So at x equals 0, we're going to be like down here somewhere. Okay, we're going to call that where it is right there. Right? So that's pretty much how you do that kind of a problem. First step is factor everything. Check to see if you have any common factors. If you do, you can go ahead and cancel them. See, like wherever the x value is for that cancellation, you're still going to need to know where that point is because that's a hole. And then once you've canceled, you have your reduced fraction. You can go ahead and check out like what are my vertical asymptotes, what are my horizontal asymptotes, in this case, what are my oblique asymptotes, and then we can start thinking about some points to graph and draw a little sketch in here to figure out what this is going to look like. All right. So on that note, I'm going to say thank you very much for watching the video, and I will see you in the next one. Take care.